The question is, what is the volume of a gas at 30 degrees Celsius and constant moles if its volume at 15 degrees Celsius is 920 milliliters? Once again, let's start off with our information. What is the volume? They're asking for a volume, so we're going to call that volume volume 1 and put a question mark. Of a gas at 30 Celsius. So that's a temperature. So we'll say temperature 1, and those two go together because they're very close in the sentence. And constant moles. This mentions moles, but it's really nothing. Anything constant means it's not changing, means we don't have to calculate it in the equation. If its volume at 15 degrees C, so this is another volume, a different volume, that'll be our volume 2. And the volume is actually the 920 milliliters. And then they also give us a temperature. 15 degrees Celsius is a temperature. That'll go along with our second volume. Now, again, you could identify this as Charles' law, but that really doesn't matter to solve the equation, to solve for the problem. We have our first group of information, and we're going to assign our PV equals nRT, the ideal gas law, to this one. So this will be 1, 1, 1, 1, 1. And we have our second equation. Our second equation is here, and we'll assign our ideal gas law to that. PV equals nRT. And these guys will be our 2, 2, 2, 2, 2. Now let's cross off everything that we don't have. For this guy, we don't have a pressure, so we'll cross that off. We do have a volume that we're going to solve for. We do have a temperature. We do not have moles or the R, so we're going to cross those off. For this guy, we don't have a pressure, so we'll get rid of that. We have a volume. We have a temperature. We don't have moles and we don't have R. So if we were to equal these guys out right now, it would look a little funny. But let's simplify what we got. We have volume 1 equals temperature 1 over here. And over here we have volume 2 equals temperature 2. So instead of putting them both together right now, what if we just mess with one equation? What about if we mess with this equation first? Well, I can move things around in this equation. If I divide both sides by temperature 2, I cross out temperature 2 on the right side, and I have this equation now. All of this equals 1, but it doesn't really matter if we write that, and you'll see why in a bit. We can also modify this equation. We can divide both of them by temperature 1. Again, that crosses out temperature on the right side. Now I can blend these two together. I can take both of them and put them into the same equation equaling each other. So V1 over T1 equals V2 over T2. Bam. There's Charles' law. Now I can put in my numbers and units. Volume 1 is unknown, so we're just going to leave it V1 divided by temperature 1 is 30 degrees Celsius equals volume 2, which is 920 milliliters, divided by temperature 2, which is 15 degrees Celsius. So I want to make sure my units match up, and normally this would be fine for most units, but with temperature, we have to make sure they're actually in Kelvin. So I want to convert these guys. If I convert Celsius to Kelvin, that's going to be Celsius 15 plus 273 equals. My Kelvin temperature here will be 288. I also want to convert this one to Kelvin. Again, 30 plus 273 equals 303. So this Kelvin temperature will be 303 Kelvin. Now I can put both of these in and rewrite this equation with the Kelvin temperatures. I'm going to start it up here. I still have my volume 1 divided by my new Kelvin temperature, 30 degrees C, changed to 303 Kelvin, equals my volume 2, which is still 920 milliliters, divided by my temperature 2, which is now 288 Kelvin. My goal now is to get the V1, the unknown, on one side of the equation alone. Right now it has the 303 Kelvin with it on that side of the equation. To counter that, I'm going to move this over by multiplying both sides by 303 Kelvin. 303 Kelvin. That means they'll cross out on the left side. I'll be left with volume 1 equals 920 milliliters times 303 Kelvin divided by 288 Kelvin. Now if I calculate 920 times 303 divided by 288 equals, my volume 1 roughly equals 968. And the units are going to be the same because we crossed off the Kelvin here. We're going to have milliliters left. Milliliters. That's my final answer.